Okay, so this is the final video in the Scratch Activity Pack series. And just like the last one, it's a bit more advanced than the first 4 or 5 or 6. I can't remember how many I've done now. And this one in particular is looking at functions. So to describe what a function is, it's basically a small piece of code. Doesn't always have to be small, but it's a bit of code that is used to perform a certain task, a specific task. And functions they're really useful whenever your maybe the program does the same thing a lot. It repeats certain tasks a lot in different places in your code. So what you can do is you can define a function. So you can give it those instructions that are being repeated a lot, and you can give it a name. And then instead of having to rewrite all those instructions over and over again, you can just write in the name of the function. Or in this case, in Scratch, you just put the block in that you've created yourself. So this is how you make your own blocks in Scratch. And the benefit of that then is that if you made a mistake when you were writing that set of instructions over and over again, if you've defined it as a function once, you only have to change it once. Whereas if you copied and pasted or you repeated it lots of times in your code, then you'd have to fix any mistakes in multiple places. So it keeps everything nice and compact, keeps your code more efficient, and it just makes it easier to work with when you're programming it. And easier, again, to see the logic in your program. So I'm going to give you a kind of a demonstration first to show the idea of a function, and then we'll move on to these tasks here. So what I wanted to show you is just a quick program. I want this cat to move forward, jump over these rocks. Okay, I'm not going to do anything particularly clever here. I'm just going to make him, first of all, glide to this rock. So if I put the glide in first. And now I want to make him jump. So what I'm going to do is, it's not going to be a fancy jump. I'm going to change the Y value, let's say by 30. So it's going to move up the screen 30 steps, or 30 pixels. Then I'm going to change the X value. I'm going to add to it so it moves across to the right. Change the X value by maybe 70. And then I'm going to bring him back down again. So I change the Y. So this time by minus 30. So it ends up at the same level where he left the ground. And that should have moved up, moved across to the right, and then moved down. Okay, so I'll then move the cat. It's going to glide to the next rock. So glide to there. And I'm going to do the same process again. So I'm going to copy and paste this to make it quicker. I'm going to move up to change Y by 30, move across to the right by 70, and then move back down. So you can see that I've repeated these same 3 steps in 2 different places here. So if I ran this, the problem we'd have is it would happen so fast you wouldn't see it. So I'm going to break it up just to demonstrate this by putting weights in between the jump in parts. Okay, I'm on there. So if we play this now. Okay, so it didn't go far enough. And the same applies to that one. And I wanted it to make a mistake there because I wanted to show you why a function would be useful here. Now, because it didn't work when I jumped over the first rock, and it did exactly the same for the second rock, if I wanted to fix it, I'd have to fix it in 2 different places. I'd have to fix this area where it's jumping. So maybe I'd put that to 50, and that 100, and that to minus 50. But that's only going to fix the first jump. So it's only going to fix that first one. Let's see if it actually works. Nope, not quite. It needs to be 150 maybe. So the second one is exactly the same because I haven't changed it. I'd have to change that code further on down as well. I'd have to change them individually. 50, 150, and minus 50. And you can see if you were repeating code a lot in a program, this would quickly become tiresome if you have to keep changing different areas of your code. Especially when it's doing the same thing. So that's fixed it. But where functions come in and where they're really useful is that I can define what a jump is, how we should jump, and then just use that one block. So in Scratch, right at the bottom of all the blocks, you've got this My Blocks area where you can create your own. And this is where you're creating a function, essentially. You're creating a block which follows a certain set of instructions that you've told it to. So I click on Make a Block, and I'm going to call it Jump. I'm just going to leave it as that for now. It's just going to be a jump block. I'm not going to put any inputs. I'll explain them a bit more later. And you get this define block. And now anything I attach to this that's going to be what the jump block actually means, what it does. So what I want it to do, I'll just copy this over. Yeah, I'll leave that in. And now I've taken this out, because that was exactly the same as what was happening down here as well. I don't need anything other than these blocks and this jump definition. And what I can do instead is use the jump block, which I've just made. And this is what the jump block does. So he moves forward, he jumps once, then glides again, moves forward, and I want him to jump over the second rock, so I put another jump block. And you can see as it runs the jump block, it moves over to show you that this is lighting up. So now, if I wasn't happy with the jump, I only have to change it in one place, and it'll change it for both of these areas, both of these parts of the algorithm. But there's also another really cool thing about functions, and that is how you can use inputs. Now say if this second rock actually was much bigger. Now I need to jump higher, but I still jump the same amount for the first one. At the moment, there's no way I can fix that using this block. But what you can do is right click over on the left here, edit your function block, and you can add inputs. I'm going to say height. I'm going to say how high I jump. And also maybe distance. So I'm putting in inputs here so that every time I use the jump block, I can say how high I want the character to jump and how far. Okay, so now you can see that there's some blocks added into the define up here. And the actual jump block here is asking for me to put values in, inputs. So say I wanted to make it jump, so it was the height first is going to be 50. And the distance across, so x, is 150. Now at the moment, that won't do anything. Because once it calls this jump block, once it sees this block, it goes over and it goes through this. And at no point is it using these values, because it's already got values in there by default. So what you do is you use these blocks. So you see the height block, that is the first input. So whatever I put in the first input box here gets stored in this height block. And I can put this wherever I want it to go in the function. So I want the height, y is what the height is. So I change y by the height. And this one is a bit trickier, which I only just thought about. It needs to be minus the height. So actually a little bit trickier. What I need to do is put in here -1 times the height, and that just makes it negative. Okay? But also the second input is distance, and I need that to affect how far it changes the x by. So what I do is I use the distance block. So now, when I reach this jump block, it looks at the inputs you put in. It says 50. Okay, 50 is the first input, which is height. So everywhere you see height, it replaces it with 50. And the second one is 150, which is distance. And everywhere you see the block distance, it replaces it with 150. But now I have the power to change those, what the jump does, how high and how far, just by changing the values in the jump block here. So the second one is bigger. I needed to go a bit higher. Maybe we'll put 90 in for height and 200 for distance. So now that same function is doing different things because I've allowed it to, I've allowed different inputs for it. So let's see if it runs. So the first jump is the same as what we had before. The second one now should go higher up and further across. Okay, I did touch the rock a little bit, but that's because the glide went too close to it. But that is why functions are powerful. You can define it once and reuse it many times. And also you can allow inputs so that you can actually change slightly what it does each time. It still does the same thing, it's still the same instructions, but you can change variables and values inside that function each time it runs, each time you call it. Whenever you use a function block, we say that you're calling the function. So that's defining the function on the right, and this is where we call the function. Okay, so that's why functions are really useful. And you can do loads of different things with functions. They just make your programs a lot more efficient and just better, really. So let's see. Oh, and a point I was going to make as well. All of the blocks in Scratch are functions. Some clever people at MIT have made these blocks. Now, behind these blocks, there's some code that you can't see. But you don't need to know how that code works. All you need to know, really, is how to use it. And that is why another reason why functions are useful. Sometimes there's some really complicated code that you don't really need to understand how it works. You just need to know how to use it. It's the same as driving a car. If you want to learn to drive a car, you don't need to know how all the parts of the engines work. You just need to know how to use the pedals, how to steer, and how to not crash or drive dangerously. So that's an idea called abstraction. That's quite popular in computer science, and it's really important. Okay, so back to the tasks. So we need to make a block, a move block, which allows you to move the character in any of the 4 directions. So one single block which allows us to move the character in any of the 4 directions, which means we'll need to use inputs for this. So if I just start a new program. Now, usually, if you've done movement in Scratch, you'll probably put when the right arrow key is pressed, up arrow key, and so on. But what we want to do here is just create our own block, call it move. And think about when we're actually making a character move, we need to know which direction it's going and how far. Okay, so we need 2 inputs. So you click on that to select an input, and you want to write in here what these inputs should be. So maybe direction. And the second one, distance. Okay. So I've got my define. Now, how do we define how it moves? Well, when the character moves, it needs to be pointing in a certain direction. So we can use the point in direction block. And we don't want it always to be 90 degrees, which is to the right. So you can see the different values here. What we want it to be is whatever we decide when we call the function. So we want to put in the direction input parameter there. And then the next thing we want to do is to move a certain distance. We don't want it always to be 10. We want to be able to use this parameter distance so that when we call the function, I can type in, so say I want to move to the right, that is 90. And if I want to move 100 steps, I put in 100 there. So he moves 100 steps to the right. But I can also use this block. Let me just make him go back to 0 at the start when I run this program. And make sure that he points to the right to start off with. So I'm going to make him go to the right 100 steps, then up which is 0 degrees to point up, and 200 steps. And let's put a weight just to see them do it in steps. Okay, so we don't, let me put a weight here as well. Okay, so it moves to the right, and then moves up 200 steps. So we've created a move block that does that. Now what would be cool is if we could, instead of putting in the degrees, we could put in a word: up, right, down, left. It's just an extra thing. But we could put in if direction equals so if the direction is up, point in direction 0. If the direction is right, point in direction 90. If the direction is left, point in direction minus 90. And if the direction is down, point in direction 180. And then after it's done that, it's checked all those different ones, move distance steps. There's a slight problem with the program that if you put in anything other than these 4, it'll do something. I guess it'll just point in the direction it's already pointing and move that way. But now, if I put up in there and then left here, it should move up 100 and left 200. Okay, so we made one block. We've defined this move block we can then use to move in any direction, up, right, left, or down. Okay, next task. Make a question block which allows you to input the question and correct answer, and then gets the character to reply if you are correct or not. Use your block to get your character to ask 3 different questions. Okay, so we're going to make a new block here. Let's just delete this. Make a block, call it, well, I'll call it question. And what does the question say? The task say? It needs us to allow you to input the question and the correct answer. So we need 2 inputs. We need the question and we need the correct answer. So those are going to be our inputs. And now we need to code a question and answer, but without actually writing a specific question and a specific answer. So what's the process of asking a question in Scratch? Well, usually we use the ask block first, but we don't want to ask a specific question. We want to put this parameter in whatever the question is when we use the func question block. That's what will be asked. And then once we've asked the question, we then check if the answer is whatever the correct answer should be. And in this definition, it's always going to be the correct answer parameter. If it's correct, then we say correct. If it's wrong, then we say not quite. Okay, and that's it. You've defined the question, and it checks if the answer is right, says correct or not quite, depending on if it's right. So now we need to actually use it. When the green flag is clicked, I want to use my question block. And in the first area, I type in the question because that's the first input here. How many planets are in our solar system? Quick quiz, see if you know it. If you studied science when I was in school, before 2006 there was 9, but now the correct answer is actually 8. Because Pluto is technically a dwarf planet. And we'll just test that that's working. So it asks whatever the input for the question was, which was how many planets are in a solar system. And then it's going to check if the answer that I type in matches the correct answer, which is an input, which I've given there as 8. And he says correct. Let's just test it works if I say anything else. 5 is not quite right. Okay, and then we can call the question again. Different question this time. How many eyes does a horse have? I don't know where that came from. What a strange question to come up with. And so now it's asking the first question, which is 8. And now, even though we've only defined it once, we didn't have to rewrite this code all over again. It's asking us the second question, and the correct answer to that would be 2. I've never met a horse with more than 2 eyes, or less than 2 eyes. In general, horses are born with 2 eyes. Okay, and then we need one more question. What will come out of my head this time? Who knows? Let's think of science. Ooh. What is our sun called? So what's the name of our sun? So the actual name of the sun is Sol. I think it comes from Latin, which is why you have certain things like Costa del Sol in Spain, which obviously translates to sun, Cirque du Soleil in French, also to do with the sun. And if I play it now, then how many planets are in a solar system? It was 8. How many eyes does the horse have? 2. And Sol is the name of our sun. I need to double check that now when I finish this video. And you could add to this. We've used variables before to check scores when we're doing a quiz. We could make a score variable. Before I start my quiz, before I start my questions, I can set the score to 0. If I get it right, then I can change my score by 1. And it's in the definition. So now, how many planets are in a solar system? 8. It adds 1 to my score. How many eyes does the horse have? 2. Okay. So again, with something like a quiz, you need to make sure you have kind of closed questions. So there's only one possible answer. I mean, with this, potentially the person could write the word 8, which would be a problem. But we don't need to worry about that too much. Okay, that's task 6.2. 6.3, we need to use the pen extension to create a block which draws a square, and the block should let you choose how big the square is. So that's an input there. If I'm allowed to choose how big the square is going to be, it's an input. Let's get rid of all this. Oh, if it says that, you have to remove any time that you've used the block before you can remove the definition, because you can't have you can't call a function that doesn't exist if you haven't got a definition. So I delete these, and then I can delete the block. Okay, what am I making? A square. Draw a square. And I need an input for the size of the square. Now, for drawing in Scratch, you need to add an extension. So you click on this button down the bottom left, add extension, and then click on pen. And what I'm going to do is, no, I won't put erasal. Need to have the pen down. To start off with, we're going to draw something. We need to put the pen down. And then how do we draw a square? Imagine if you're walking around on the floor, how would you walk in a square? Well, I need to first move forward a bit. So I need to move the way I'm facing. Let's leave it as 10 steps for now. And then I need to turn how far? So for a square, I turn 90 degrees. That's the angle on each corner. So I need to find turn. I'll turn right 90 degrees. And then you repeat that again. You move forward, you turn right. You move forward, you turn right. And you do that 4 times. So actually, this is going to be a loop. We're going to repeat these 2 steps 4 times. So I can put 4 in there. And I think that should work. But the question said we need to be able to say how big we want the square to be. So instead of moving 10 steps every time, we should use the size block. So that when I call the function, when I call it using this block, I can put in whatever size I want, and it'll move that certain amount of steps. I'm just going to reset the character to the normal starting position, 0, 0, and point in the right direction as well. And I'm going to make a square of size 50. Okay, so you can see it's drawn a square. If I want the square to be bigger, I'm just going to erase all at the start as well, so it doesn't draw over the last square. I can just change this value to be 100. Oh, there you go. So because pen was still down there, when it moves from here back to the start, maybe I should put pen up, then it moves to the starting position, then I say pen down, which is in there. Okay. So now it's made a square of 100. So I can draw multiple squares if I wanted to. I'll draw a smaller one inside that one. Okay. So I can use the same block to do different things. And that's it. So I made a draw square block. And finally, the challenge task. So slightly more tricky because you need to know a bit of maths to be able to do this. We need to edit out block so that I can make any regular shape, not just a square. So what do I need to change? Well, I can leave size because all size does is it changes how long each line is in the shape. So I need that because I can then decide how big each shape will be. But what here actually makes it a square? Well, the number 4 does, because it tells me how many times, like how many sides I'm drawing. So I know I need to change that. And the amount you turn. With a square, you turn 90 degrees. With a triangle, you turn more. You turn 120, I think. Let me have to check that at some point. Yeah, 120. And then with more sides, you would turn a little bit less. So with a pentagon, I think it would be about 72. And the way you can work this out is you can think about if you turn in a full circle, that is 360 degrees. So for each side, you need to turn a certain amount of the 360. With a square, there are 4 corners. So you can do 360 divided by 4 to find out how much you turn each time. And that's 360 divided by 4 is 90. With a triangle, you need to turn 3 times. There are 3 points in a triangle. So it's 360 divided by 3, which is 120. So I was right. And so on. So it actually depends on how many times you're repeating here and the angle. So it depends on the number of sides of the shape. So this is a bit tricky on how to do this, but we need to add another input here. And this is going to be the number of sides. So how many sides do you want the shape to have? And also we need to make sure we actually name the function sensibly. It's not always going to be drawn a square. So we're not going to call it draw a square. We can call it draw a shape. Okay. So now, number of sides. So for a square, it's 4. But we want to draw any shape, so we leave it. We put this number of sides in here. So however many number of sides they put in, that's how many times we need to repeat these steps. And then the slightly more tricky part is the amount you turn. As I said before, it's 360 divided by the number of sides. So we need to put a little equation in here. we need the divide block. And the first number is going to be 360, because it's always 360 degrees in a full turn, a full circle. And we divide by the number of sides. So again, we use this block. Now, if I want a shape, say I want a square, size 100, that's fine. But what if I want a pentagon of size 50? Then I can put 5 in here, because that's the number of sides that I'm choosing. So you can see it drew a square first, and then it drew a pentagon with 5 sides there. So now I can make any shape with this. If I want a shape of size 50 with 10 sides, then it makes a decagon. If I want a shape with 9 sides, it makes a nonagon. Okay, so that is how you would make a function to draw any shape, and you can choose the size of it as well. And that's the challenge task done. So there's so much you can do with functions. You can pretty much do anything with functions. It just takes a bit of playing around. Just think, if you've ever written a program where you're doing very similar things more than once, is there a way you can either use a loop to do that, or is there a way you can write a function and define it and then just reuse and call that function when you want to? It'll start making your code a lot easier to read. You can break it down to nice steps. Maybe you've got different sections. I can't think of an example now, but maybe you had a menu part that comes up first. Then you have a question part, and so on. You could break those down into individual functions so that your actual main algorithm is just some of these blocks. But don't overdo it. You don't need to make everything into a function. Okay, it's about being sensible about when you use it and when you don't. So that's the end of the Scratch activity pack. If anyone's made it this far, then well done. I am impressed. And hopefully you've gained a lot of programming knowledge in Scratch. Now remember, Scratch isn't the... you're not going to go and get a job making Scratch programs like me, unless you're very lucky like me. So I'd recommend moving on to some other languages. If you really understand these in Scratch, try and apply the same concepts now in another language, either Python or Java, or just any other language that's more of a written one. And you'll be well on course to making a good career out of this. Okay, so I hope you've enjoyed, and thank you for listening.